All right, in this introduction video, we're going to be talking about chemical bonding. The first type of bonding that I want you to know about is ionic bonding, which is bonds between positives and negatives, and occurs whenever a metal and a nonmetal are bonded together. For doing this, we always want to make sure that we have the same number of positives and negatives and charges together. So, like we've already seen in class, if I bond sodium and chlorine together, sodium gets 1 valence electron and chlorine has 7. So sodium would make an Na plus ion and chlorine would make a Cl minus. Since that plus has a minus, the compound would just be NaCl. For barium and fluorine, barium would have 2 valence electrons and fluorine has 7. So barium would make a 2 positive ion and fluorine would make a 1 negative. So barium's 1 positive goes with fluorine's 1 negative, but now I have an extra positive here, so I have to get another fluorine to pair that up with. So the formula would be BAF2. For aluminum and oxygen, aluminum has 3 valence electrons and oxygen has 6. Okay, so aluminum would make a 3 plus and oxygen makes a 2 minus. So 1 plus, 1 minus, 1 plus, 1 minus. I have an extra plus from the aluminum. So 1 plus, 1 minus. I have an extra minus now from the oxygen. So I need to pull in another aluminum. 1 plus, 1 minus. And now finally, I have that. So I ended up with 2 aluminums and 3 oxygens. Now some of you from right away maybe could have seen that, hey, if I've got 3 positives and 2 negatives, the number that they're going to have in common is going to be 6. Because if I take 3 times 2, I get 6. If I take 2 times 3, I get 6. And you can figure it out that way. But if you can figure that out, go for it. But if not, you should be drawing them out until you do get the hang of this. Not all ions are made out of only one element. So some ions are called polyatomic. So it's a whole group of atoms together that all together have a charge. So we treat them as one unit. So if I'm trying to combine sodium with the sulfate ion, the SO4 2-, sodium, like we talked about before, has 1 positive. Sulfate has 2 negatives. And so I'm going to need another sodium to go with that sulfate. Okay, because remember the 2 negatives is on this whole thing. The 4 has nothing to do with the charge. The 4 on the sulfate means that we have 4 oxygens. So sulfate actually looks like this. And this entire thing has a 2 negative charge. So when I write out the formula, it would be Na2SO4. So 2 sodiums, 1 sulfur, 4 oxygens. If I'm doing barium nitrate, barium, just like we discussed before, has 2 positives. Each nitrate has 1 minus. Okay, so again, nitrate is N with 3 O's around it. And this entire thing has a 1 negative charge. So I got 1 plus, 1 minus. So I've got to add in another nitrate for another plus, another minus. So I end up with a Ba. And then to say that there's NO3, to say that there's 2 of them, I put it in parentheses. So then that 2 applies to everything inside the parentheses. The other kind of different thing about ionic bonding is when you're dealing with transition metals that can have more than one different type of charge. So to be able to try to figure out what charge does it have. So if we look at Fe2O3 versus FeO, let's actually start with FeO first. So I don't know what charge Fe has because it's a transition metal, it can have more than one. I do know that because oxygen has 6 valence electrons, and we've kind of is that oxygen will have 2 negatives, and we'll practice some more figuring out charges. So if I only have 1 Fe and 1 O, that means that this Fe is 2 plus. Okay. Whereas if I have Fe2O3 and I have 3 oxygens and each one has 2 negatives, and I only have 2 Fe's to go with it, well then I need to have 1 plus for each minus, so I have 6 minuses, so I need 6 pluses. So these 3 pluses go with this iron, and these 3 pluses go with this iron. So in this case, it was Fe3+. Whenever you're naming ionic compounds, you're just naming them with, you put the name of the metal first, followed by the name of the nonmetal, but you're changing the name of the nonmetal so it has an "ide" at the end. So for example, NaCl is a familiar compound. So Na, if you look on the periodic table, is named sodium. And then Cl is chlorine, but in a compound, to designate that it's in a compound, we change it to be chloride. Okay? So we're just changing the ending of what's on the periodic table. If a compound includes a polyatomic ion, you'll look up the name of the sheet on name of the ion on your ion sheet. So for example, Na2SO4. Again, we go to our periodic table. We find that Na is named sodium, and then SO4 we'll look up on the sheet, and you'll find that it's named sulfate. Okay, so that's just the name that's been decided on for that. If you have compounds that are with transition metals, what you need to do is you need to name them based on which state the metal's in. So again, going back to the example we just did, FeO versus Fe2O3, we found that FeO was iron 2+, so we would name this iron 2 oxide, whereas with Fe2O3, we would name this one iron 3 oxide. A lot of times people think that the 3 here goes with one of these numbers. These numbers here are the charge on the ion. They have nothing to do with the subscript. So the charge is 2. What we put in parentheses is Roman numeral 2. If the charge is 5, we put a Roman numeral 5. It has nothing to do with how many things there are, at least not directly. The other type of bonding we have is covalent bonding, which is 2 or more nonmetal atoms held together by sharing electrons. So when we're naming these, it's similar to what we had before, where we just give the name of one element and then the name of the other element. But now in blanks, we're going to put prefixes that are listed here. And the reason is when things are bonding covalently, there's so many different ways to put things together. Like for example, I could go like OF2 or OF4 would also be possible. So because there's more than one way to put things together, I need to be able to designate. So this would be oxygen difluoride, and this one would be oxygen tetrafluoride. If I wanted to, instead of putting charges together to make the compounds, because covalent molecules can go together in so many different ways, one of the things we'll practice with here is just drawing out what the molecule would look like. And I don't know if we'll do a lot of this, but I want you to have at least seen it. We'll do like a few, probably some of the just simpler ones in class. Okay, so when we're trying to figure out like what would CO2 look like, how does it share? I start out with, well, if it's C with 2 O's and carbon gets 4 dots because it's in the 4th column, and oxygen gets 6 dots. And I always put the dots around like just in one direction. Whoops, I accidentally put 7 dots on. So get rid of one of those. And this oxygen gets 6 as well. All right, and I just like goofed up how I did the dots here. Let's get rid of that one. Okay, so what you do is you can say, okay, now how can they share to be happy and get 8? So if this carbon shares here with this oxygen and here with this oxygen to make what's called a double bond, then that oxygen is happy because it has 1, 2, 3, 4, 5, 6, 7, 8. And then if it shares with this oxygen here and here, then it's happy with 1, 2, 3, 4, okay, 5, 6, 7, 8 for the carbon, and the same for the oxygen. Okay, so we can rewrite, we can clean that up a little bit, and we can draw the structure like this. And again, we'll practice this in class some more too, because a 15-minute video doesn't give me a lot of time to show you lots of different practices, where each one of these sticks means 2 shared electrons. Okay. Now, if I'm doing carbon monoxide, I start with carbon has 1, 2, 3, 4, and oxygen has 1, 2, 3, 4, 5, 6. Okay. So if I want to make it happy, okay, so again, I can share this electron with the carbon, and then I can share this electron there. But now carbon still only has 1, 2, 3, 4, 5, 6, even though oxygen's happy with its 1, 2, 3, 4, 5, 6, 7, 8. So what I do then is if I can't make one of them happy, then oxygen's just going to have to share 2 completely over. So what I ended up with carbon having 2 of its own, sharing in 3 places with the oxygen, and then oxygen has 2 of its own. Okay, and again, we'll practice with these. All right, so that's all we have for starting. Okay, hopefully this has been helpful.